Next guest speaker has a team of people, and while they come to the stage, you'll find out that there's no death by PowerPoint here. You're probably thinking the brightest minds are at the universities. Well, today they're not, they're here. And that's their car out there, and same with the racetrack simulator. They developed an e-racing car formula system, and we have the team principal and the team leader and her team from the University of Wollongong. Ladies and gentlemen, please welcome Claudia Muller and team. Do you want that so you can pass it around the group?
That's right. We'll just, yeah, thank you. Ooh. Hello everyone, good morning. So my name's Claudia, I'm the team principal for UOW Motorsport for 2019. It's a pleasure to be here this morning. I just want to start off by asking if anyone's actually heard of the SAE competition before, the Formula Student Competition. Oh, cool. Okay, a few people. All right. So I'd also just like to introduce the people that are up here with me as well. So I've got Stephen Adams, who's our current technical director for this year, and Andrew Wilkie, who is our electrical coordinator for this year as well. So I'll just start off with telling you a little bit about the team. So UOW Motorsport is a student-run organisation operating within the University of Wollongong. So we design, develop and manufacture and race our electric formula-style vehicle that some of you might have seen at our stall already today. So we do this from scratch each year, and we compete against roughly 600 other universities across the world. So the team is a fantastic opportunity for students on campus to hone their skill and take that classroom knowledge and understanding and turn it into something that's tangible and something that they can be proud of and also show to employers. So we're very fortunate to have the support from the university to be able to do this, and not just for engineering students, but also for marketers, designers and creative students, from the way that we've structured the team into technical, business and race divisions, which we'll touch on a little bit. So the result of this is quality graduates with the capability of diving headfirst into industries like this one, bringing the problem solving and design understanding with them that simply cannot be replicated in a classroom. So we've been building our team to prioritise this over the last few years and give students extraordinary opportunities. That's something that we're very passionate about at the team. I don't know, I speak for myself in this, but I definitely, when I started uni, I didn't imagine a project that would bring me to an event like this where I could test drive a Tesla. So the competition itself at the end of each year is a really big challenge for us, and although the car has to perform dynamically, it is a design and engineering competition in a sense that all students need to be able to justify their design decisions, present a business logic case, and also justify the cost associated with manufacture. So I'm sure you wanted to hear a little bit more about this, so I'll pass you on to Steve and Andrew, and they'll talk a little bit more about the car itself and kind of how we set this up and how we achieve this each year.
Thank you, Claudia. So what I'll do is I'll just start off with a general overview of the competition and what we're actually designing the car for. So as Claudia said, competition against 600 other universities, but the main format of racing is all time trial based. Obviously it's student designed, student built and student driven, so can't go racing wheel to wheel, sadly. So what it is you grab a regular circuit, you put cones all over it to kind of slow it down. So we're looking at an average speed of around 60 kilometres an hour with a top speed of up to around 130. So with that in mind, we're designing a car for a specific set of rules as well as a specific format of racing. So what I'll do is I'll tell you a little bit about the car. So it's over there if you want to come have a look later. But looks like a Formula One, kind of scale it down, but still definitely bigger than a go-kart. So we're on 13-inch wheels. They're about that big or so. That's the rims at least. But the more importantly is the powertrain. So what we have two independent motors, the MRAX 188s, and they drive the rear wheels separately. We've got two motor controllers as well. That allows us to do cool stuff like torque vectoring as well as traction control systems independently for each rear wheel. So we can make the car turn faster around corners than most regular cars, definitely faster than internal combustion cars. As well as the accumulator. So the accumulator we have runs at 400 volts, which is higher than most cars around here other than the Teslas, I believe. And we can discharge up to 200 amps. So with a peak power output of 80 kilowatts, that's limited by the competition, we can do 0 to 100 in about 3.1, 3.2 seconds. That's because our car only weighs just over 200 kilos. So 200 kilos, 80 kilowatts, you can do the maths. That's a very good power to weight ratio. Along with that, to control this all, we have a custom-built VCU, Vehicle Control Unit. That takes in inputs from a lot of sensors. We've got multiple CAN buses among the car, and they all deliver the data to the VCU, and we can make a lot of decisions based on that, telling the motors and motor controllers how we'd like the vehicle to perform. Just touching on the mechanical side of things a bit, the entire car that you see there, we design and build from scratch. Every component that you see on there has either been selected and purchased off the shelf for a specific reason to be integrated into our designs, or anything else that we have, we've actually designed in-house and done ourselves. A perfect example of this, Chris Woon, the man on the camera at the moment, he designed our uprights, the uprights being part that connect the wheels to the tyre and the hubs. So the kind of design process that we go through with this is we start off at the beginning of the year with a set goals, what we want to do, say achieve a vehicle acceleration of 1.2 Gs, corner, maybe 2.3 Gs. And then we go through all of what the vehicle mass would be, and we start doing some sketches just on pieces of paper and how we want it to look. Then we start with the full engineering method. We go through designing it in CAD, going through finite element analysis, making sure the components aren't going to break. And that's typically as far as you get with a university degree. However, we take it that one next step further. We actually then go ahead, we manufacture the parts, whether we manufacture it ourselves in our own workshop or we get the components outsourced, send it to some other companies to make them for us. Once we do that, we then get the components back and we can actually put them on the car, test them ourselves, and you get to go get a much better experience at university than you do just going through the degree. It's at least how I see it. So what I'll do is I'll pass over to Andrew and he can talk a bit more about the electric side of the vehicle. Thank you.
All right, so now the electrons, the part we all came for. So I'm the electrical coordinator, so I oversee all the electrical side of the car. So that's the high voltage system, so the 400 volts and the accumulator, as well as the low voltage system, so how we control the vehicle. As Steve mentioned before, we do design our own custom vehicle control unit, and this is one of them for this year. It looks pretty straightforward, but we take that vehicle control unit and we design it all ourselves. So the goals that are set by what we want the vehicle to achieve, they're also set electrically, what we want it to do, like whether it's reliability, power output, or efficiency, or all of them combined. We take those goals, we design our schematics, we then test them in simulations to see how we go. We breadboard them as well. You guys might have done that with, Arduinos, etc. We also take that and we design it in CAD as well. So we do our circuit board design. We'll send those off and get them manufactured. And the other cool thing is we will solder these ourselves. So that teaches us how the boards are put together as well. So if we're ever to design them again, say, why did we design it this way? It was so we can manufacture it. Yes, most stuff like the Teslas will have computer placed machines to do their circuit boards, but we'll solder them ourselves just to give it a little bit of extra practicality for when we enter the workplace. We also do the software ourselves, so the VCU is custom designed and custom programmed, so that means we can control how much torque we put to the wheels, how we interpolate our data, how we control the vehicle directly, which is pretty cool, which it makes us do the cornering faster and allow us to, if our battery's draining, control how much power we're using to conserve our energy around the track. I guess I'll finish there.
So yeah, as you can probably gather, what we're trying to do is give students an opportunity to kind of use the skills that they're learning in class to try and produce something. And because we're working with a lot of real companies and sponsors and manufacturers and things like that, that they are really thrown in the deep end and forced to kind of use proper communication skills to try and achieve what they want and be open to iterating and changing their designs as well. So I will just tell you, our competition is in December and January, so if you did want to stay up to date on kind of how we're doing, you can always find us at the store to find out how you can keep in contact and things like that. But I think what we'll do is we'll open up for questions if anyone wanted to ask specific things about the vehicle or how we operate as a team.
Well, good. We might catch up the time that we're behind.
Sorry, I must ramble a bit, but I'm a member of AUSHPV. Yeah, Australian Human Power Vehicle Association, and you know that there's a competition of the velomobiles, at South Australia and Victoria, where they race these velomobiles which are. Yeah.
We're 25 minutes behind.
Okay,
So
okay
it's a
then.
question.
Yeah, okay then. Yeah, and then my question is, it's about EVs, and we know that in Australia, these velomobiles have already been. There's an e-bike on it, and they are like quite fast velomobiles. So it's a human-powered and with the electric assistance, and it's already been built here. So I'm kind of asking is which of the direction it should go? Is it much more or Australia should go? Because from history, and I think there's velomobiles, a human powered with electric assistance. There's already been a case here, and it's a big thing in South Australia because it's not the university students that do it. It's actually I think the middle. The middle school.
Hang on, stop. We'll book you in as a speaker for next year. I'm not sure what the question was. Can you pedal an EV in Formula racing? No.
At this point,
You
no,
can,
we
but you'll
can't.
come last, right? Like the Kiwis did yesterday. Any Kiwis in the room? Is there a genuine question? Or you guys are just out there, aren't you?
Yes.
Just over
And
the
haven't you
road.
got the racing virtual simulator as well?
Yes, we have the simulator as well.
Okay, so we don't want to hold you up. And you would do me a great favour if we can bring everyone happy to go and ask questions live at the display so we can kind of catch up. Right, big hand, ladies and gentlemen,
Thank
for
you
the
for
team
having
from from Wollongong. Thank you. Great job. Now I'm going to have to go and find Rebecca. Dun, 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 dun. Can I ask you a favour? Yes. Oh, cheers. It's all right. Great. Yes. Thanks, mate.